Welcome to EDU World Space.
This question asks us to write the electron configurations for the following ions and determine which have noble gas configurations. So the first one is cobalt 2+. Cobalt is right here, number 27 in the periodic table. So in its ground state, or in its non-ionic form, cobalt have electron configuration of argon, 4s2, 3d7. And so if this is cobalt 2+, we're going to remove 2 electrons. We'll remove those from the 4s orbital because it's higher in energy than the 3d. So if we take 2 away from the 4s, we're just left with the 7d electrons. So electron configuration is argon, 3d7. Okay, next is tin 2+. Tin is right here. Normally, it does have an atomic number 50. Its normal electron configuration is krypton, 5s2, 4d10, 5p2. So one more time, 5s2, krypton, 5s2, 4d10, 5p2. And if we're going to take 2 electrons away, we're going to take them away from the p orbitals, the 5p orbitals. Those are higher in energy than the 5s's, which are higher in energy than the 4d's. So tin 2+ would have the electron configuration of krypton, 5s2, 4d10. Then we have zirconium 4+. Zirconium is atomic number 40. So normally electron configuration is krypton, 5s2, 4d2. And if we're going to remove 4 electrons, we'd move them from the s first, then the d. But since there's only 4 valence electrons, this would remove all of them and leave us with the electron configuration of krypton, which is a noble gas configuration. So I'm just going to write Ng here for noble gas. This is silver plus, so this is Ag plus. Silver here is number 47. Normally its electron configuration is krypton, 5s2, 4d9. If I remove 1 electron, I remove it from the 5s, so I would have 5s1, 4d9. But this is one of those exceptions where moving that electron from the 5s to the 4d will give you a full 4d orbital, which is more stable than having 9 electrons in the 4d and 1 in the s. So this one is one of our exceptions, but it is going to be krypton, 4d10. And finally, we have sulfur 2-. Sulfur here is number 16. Normal electron configuration is non, 3s2, 3p4. That would make our, if we gain 2 electrons, we would put them in the p orbital to make it 3s2, 3p6, which is the electron configuration of argon. So I'm going to write argon here. And again, that's a noble gas configuration.